Okay, this talk I'm going to do now is about voltage drop. This one is one of the different questions you get in the LET. I'm going to show you two videos. This one, and then I'll do another one about the more generic one that happens to appear on the papers all the time. But anyway, the reason I'm doing this is one way shows you how to do the one formula and the other one uses the other formula. So if we come over to here, in page 91 of the 3008 book, we have two different formulas. This one we're going to be using because we don't know the size of the cable. The cable size is unknown. And if you look in this question, there's nothing about the size of the cable mentioned at all. We have the 92 metres, we have the 40 amps, and we have the maximum voltage drop. Now, if we look at the other question over here, it talks about voltage drop. Normally you have to have the cable size is known in the question. Anyway, we'll do that in another video. We're going to concentrate more about this question here. So what they're asking for us to do is find the minimum size conductor and the voltage drop at the motor terminal. So I'm going to go through this step by step on the paper and just show you how it works. So the first thing we have is we have this formula, 1000 times voltage drop divided by L times I. Now, the thing I like to do is VC, I and L out of the question. So the thing I like to do, come over here, we had 92 metres, we had 40 amps, and we had a voltage drop of 11 volts. So if I come over here to put them into the question, we now have 1000 times 11 volts divided by the length being 92 times the current, 40 amps. So we've got 11,000 divided by, now we'll do this on the calculator, 92 times 40 equals 3680. So now we divide 11,000 divided by 3680 and we get 2.98 millivolts per amp meter. Now where am I getting that from? Alright, if you look over here, and I'll go to the table. So we've looked at our voltage drop, we go to our tables. Now the thing on this one here is we need to work out what the cable's doing. The cable is copper conductors installed unenclosed in a single configuration, open to air and protection HRC fuses. So it's unenclosed and it's just a 4-core over here. That means we're looking over here. So if we look at table 42, it says 3-phase multi-core cable, all right? Now, if you notice before, zooming down here, that this is millivolts per amp meter. So the one I got before was 2.98, right? 2.98. So what I need to do now is come down. Now, the question also said it was at, we need to look at the temperature. Cable supplied by V90, sorry. V90 is 75 degrees. We can find that on table 1 on page 14, and it actually says it's 75 degrees. So I'm going to now go 75 degree column, come down. Now 2.43, if we zoom in on that, is lower. It has to be equal to or lower than 2.98. So that equals, 16 millimetre. All right. So my answer is table 42 at 75 degrees, which is going to equal 16 millimetre squared, which is 2.43 millivolts per amp meter, and that equals to 2.98, which is what the value I got under. Now, the problem I got, they want to know the motor voltage terminals, the terminals at the motor terminals, right, the voltage. So the next thing I need to do, we have to use the other formula, voltage drop, all right, because we need to work out the voltage drop on the length of this cable for the 92 metres. So voltage drop equals L times I times VC divided by 1000. The length I've already got right, which is 92. The current is 40. Now my VC value happens to be 2.43 from the cable. So 2.43 divided by 1,000. And this, the answer will be in volts. So let's have a look. 92 times 40 times 2.43, right, equals, divided by 1,000, equals 8.94 volts. So that's what we got on that voltage drop of that cable for that length. So what I need to do now is go 400, take away 8.94 volts. So 400 on my calculator, right, take away 8.94 volts. We have 391 volts. Now, the thing I got, how does that work with the 5% rule? If you look at the rule, 3.6.2 on the AS3000, right, it says 5%. All right, and that's of the total furthest point in the installation. So if we go 5%, so 400 times 0.05, that'll equal 20 volts. If we're doing 230 times 0.05, it'd be 11.5 volts. All right. So if we look at 380 volts, if it's above that on the 400 volt scale, 380 volts is a minimum cut-off point, and below that it fails. Above it, it passes. So we have 391 volts, which is at our motor terminals, but it's within the guideline of the rules. All right. So if you have a look at this, this is my first answer for A on this question here, minimum size conductor. And the voltage at the motor terminals happens to be this one, which is 391, which is number B. All right. So I hope that has helped you. I'll go through the third, another voltage drop one, which is probably a bit longer because we have to do 2 cables, but we'll attack that later and we'll have a look at that question as well.